Okay, so this is section 12.1, law of cosines. I'm just going to go through some of the examples on the notes and then a couple extras for you guys to see. So this is the law of cosines that's written on your guys' notes. Really, for the most part, I don't really want you guys using these. You should be doing the work to get to those. I feel like it's kind of a cheat to use those ones. And really, if you're looking at the law of cosines, you guys, most of the time, if you take your trig class in college or something like that, they're not going to let you use a formula sheet. Those formulas on the right-hand side are a little bit tricky to memorize on top of the ones on the left-hand side. If you look at the ones on the left-hand side, this is all just Pythagorean theorem. And then whichever side you're using, that angle is the one that corresponds with it. So whichever side it equals squared is the angle that corresponds with it, and then you use the other two sides times 2 times the cosine of that angle. So I feel like this is pretty easy to memorize those three. They're all just a variation of each other. So whichever side you have on this left-hand side, you're going to use the other two on the right-hand side. So I don't feel like these are that bad to memorize, but you definitely need to have these memorized if you're going to end up taking a trig class in college. So there is one last thing on here that's important. It's that bottom part where it says you can use the law of cosines to solve a triangle when you are given the following information. 2 side measures and the angle between them, so side, angle, side, or 3 side measures. Otherwise, you're going to use law of sines, which we already did. So here's our first example. It says we want to use the law of cosines to solve this, which absolutely makes sense because we're given side, side, side. With that being said, we want to find angle B. So I'm going to make my equation equal to side B squared first. I'm going to go ahead and label these because these are kind of tough to use if we don't have them labeled. So the angle, or the side across from B, angle B is B. The side across from angle A is A. The side across from angle C is C. So my law of cosine says I'm going to take whichever angle I want, and I'm going to take the side that corresponds it and square it. And then that equals the other two sides squared and added together, minus 2 times those two sides, so AC, times the cosine of the angle that I want. So you really don't have to look at your formula sheet all the time. You're just thinking about this and what it says that formula wants. And just do the variation of that. You don't have to memorize 3 formulas. You just use that pattern and write the formula that you need. So now B is 316, so we're going to write 316 squared equals A is 155, so we've got that squared, plus C is 197 minus, minus 2 times A times C times the cosine of B, and we don't know B, so we're just going to write cosine of B. Now, I'm going to put these in my calculator individually so that I can now solve this. 316 squared is at 99,856. Then we've got 24,025 plus 38,809 minus, and then if I multiply these 3 things together, I get 61,070, and then we still have the cosine of B. Now, I'm going to kind of simplify this a little further and go ahead and add those 2 numbers at the front. We get 62,834, and then we still have minus 61,070 times the cosine of B. And we're really trying to solve for b here. So we're going to solve this just like an equation. Like I always tell algebra kids, draw your balance line. We got to subtract 62,834 from both sides. These go away. And on the left-hand side, we are left with 3,702. On the right side, we're left with negative 61,070 times the cosine of b. The opposite of multiplication is division, so you're going to divide by that. And when we do that, we get, oh, I'm actually missing a 2 here. So when you do that, fix that 2. Sorry, I forgot to write it down. Then we get negative 0.60622, and it keeps going. Is approximately, because we're not writing them all down. The cosine of b. When you do this in your calculator, we're going to take the cosine inverse here. So do cosine inverse, and then go up to your number, type enter, and it'll bring that whole decimal down. So you're not typing in all of those decimal places. So let's go ahead and do that. We're taking the cosine inverse of both sides to get rid of that cosine. When you do that, you get 127.32 degrees is, well, we probably should write approximately here. Approximately B. So we'd write 127.32 degrees. If you look back at the word example at the top of your page, you guys, it's just talking about the angle of those dinosaur feet, so it's really just wanting b. If it asked you to solve the whole triangle, then you'd have to continue, you'd have to do log cosines again, and then some extra math. Alright, the next one is just a flat out solve for x. We want to get that side x there. So you guys can see I already labeled my angles. I just pick which ones I want to be A, B, and C. And that's just the ones I happen to pick. You could label them A, B, C in any order you want. It doesn't really matter. It's just going to correspond to whatever formula that you use. So my side across from angle A is side A. My side across from angle B is side B. My side across from angle C is side C. We definitely want side C, so we definitely have to make this C squared equals, because that's what we want. We got to have C equals there. So then we're going to take the other two sides, square them, so we've got B squared plus A squared, add them together, minus 2 times those two sides, times the cosine of the angle that corresponds to whatever side is here, so cosine of C. Okay? Now, let's go ahead and replace our stuff in here. C is actually x in this case, so I'm going to label that as x squared instead. Then we are going to have 12 squared. I'm just replacing A, B, and C in here. 11 squared. Then we've got minus 2 times 11 times 12 times the cosine of C is 22 degrees. It is important to make sure that you have your calculator in degree mode. If you don't, you're going to be getting the wrong answers on this. So if you didn't get the right answers on the last one, chances are that's why. So now we've still got x squared. And we're going to just type this whole thing in our calculator. So go ahead and type that whole thing in. Pause the video for a second so you can do that. Okay, when I do that, I get approximately 20.2234, but we still have x squared equals, so we got to take the square root of both sides to get x by itself, and we get about, I'm going to write approximately 4.5. You get 4.497, we'll just do 4.5, so that's our answer. X is approximately 4.5. Alright, I like to with these, you guys. This has X, Y, Z. I just like to stick with A, B, and C. So I'm going to go ahead and make these A, B, C. So I'm going to say this is A, this is B, this is C. And then my side across from B is side B, side across from A is side A, side across from C is side C. We want to solve this whole triangle, so in all honesty, it really doesn't matter which one you pick first, so let's just do B. So B squared equals A squared plus C squared minus 2 times A times C times the cosine of B. So I don't have that memorized by any means, you guys. I just know that I'm going to take my side I want. I'm going to add the other two sides squared on the other side. And then I'm going to subtract 2 times the other two sides. Then multiply by the cosine of the angle that corresponds with that side. And then I'm just going to go ahead and plug my stuff in there. So we've got B is 23 equals A is 15. Plus C is 17 minus 2 times A times C times the cosine of, and we don't know B. We're trying to find that out. So let's go ahead and put those in our calculator. So 23 squared is 529 equals 15 squared is 225 plus 17 squared is 289 minus, we've got 2 times 15 times 17 is 510 times the cosine of B. Now I'm going to add my 225 and my 289 and I get 514. And we've still got minus 510 times the cosine of B. So I'm going to go ahead, draw my balance line. I'm going to subtract my 514 to move it to the other side. So we've got 529 minus 514 is 15. These two went away, so we still have equals negative 510 times the cosine of B. So if we go ahead and keep solving, we're going to divide by negative 510 just to get that away from that cosine of B. And we get negative 0.029411765. Honestly, you guys, I'd probably type all those in. Is approximately cosine of B. Unless you're just taking your answer, pressing enter, and putting it in there to do that cosine inverse. Because those really are important digits on there. So we want the cosine inverse of both sides. So let's go ahead and type that in. And we get 91.6854, and it keeps going. So let's just do 91.68. So let's just do 91.7. So we've got 91.7 degrees is approximately B. So we do want to label that on there probably, so 91.7 degrees. All right, but we are not done. So it says solve this triangle. So we have to have every single angle and every single side. Once we've got two angles, pretty darn easy, just subtract them from 180. But we're not really there yet. So let's write B, let's write the measure of angle B equals 91.7 degrees over here, and then I'm going to erase all this work. So if you need it, now's the time to write it. All right, so there's a couple different ways we could do this. I could use law of cosines again, because this is the law of cosines notes. I'm going to use law of cosines. But at this point, you guys, you really could use law of sines. I like law of sines better. So maybe I'll just show you both ways. I just think law of sines is so much faster and it is so much less work. So if you want to use law of sines, at this point, by all means, use law of sines. That's what I would do. I'm going to show you both because you probably need some practice with law of cosines because you're just now learning it. But I will show you both ways. Alright, so here's both of these methods. If I were to do law of sines, I definitely have to use b because that's the only one I have the angle as well as the sine for. So I would do 23, which is b, over the sine of b, which is the sine of 91.7. You can write degrees or not write degrees. It's not a huge deal. This is just your work. Equals, let's just do a. So 15 over the sine of a. You guys know I like to call this sombrero method. I just think it's funny more than anything. But really, you're kind of cross-multiplying here. So make your sombrero. We've got 15 times the sine of 91.7 divided by 23 equals the sine of a. When we put that in our calculator, let's see, we get approximately 0.65186. That's all I'm going to write down. Then we've got the sine of a. So now we need to do the sine inverse of both sides. And once we do that, we're going to get approximately 40.7. And this is degrees for A. So we're going to say the measure of angle A is 40.7 degrees. And then we could go ahead and subtract those from 180 to get that last angle, which makes that last angle, so the measure of angle C, that makes that 47.6 degrees. Now, I'm going to go ahead and do law of cosines because that's also important to know. I like using law of sines at this point just because it's so darn short. But you can definitely use law of cosines, and I'm going to show you that just because this is law of cosines notes. So let's go ahead and do angle A. If we're going to do angle A, I need side A squared equals B squared plus C squared minus 2 times B times C times the cosine. My angle needs to be A because I'm using side A on this side. So let's plug it in. We've got 15 squared equals 23 squared plus 17 squared minus 2 times 23 times 17 times the cosine of A. We don't know A. That's what we're trying to find out. Let's go ahead and plug those in. What's 15 squared? We've got 225 equals 23 squared, which is 529, plus 17 squared, which is 289, minus, we're going to do 2 times 23 times 17. Whoops. $782 times the cosine of A. I can go ahead and add these two things. So 529 plus 289 is 818 minus, we still have 782 cosine of A. I'm going to start running out of room here, so I'm going to write little minus 818 from both sides because we're solving this like an equation. So 225 minus 818 is negative 593, and we still have negative 782 cosine of A. Okay, go ahead and divide by that negative 782. And you should get approximately like 0.7583, and this is going to be, keep going, equals approximately the cosine of A. And then we got to do the cosine inverse of both sides. My work's getting kind of sloppy. I apologize. And we get A is approximately 40.7. 0.7 degrees again. Same thing. That's good. That's a good check there. You get 40.68544, and it keeps going, but let's just round to one decimal place. And then you do the same thing again. You'd subtract those two angles from 180, you get your 47.6 degrees. So this is how you would do that problem. Go ahead and try this last one. If you're not being honest with yourself and actually trying this one, it's a lot tougher to learn, you guys. The reason there's these you try problems is because it is a whole different level of learning when you see what mistakes you made. It is so easy to just keep watching these and think, oh man, I can do that. That looks easy. It always looks easier when you're watching it. That's just how math works. But then when you go to try something, you'll figure out the things that you don't remember how to do or you don't know how to do. And that's good. If you try this problem and you only get one little part of it done and then you're like, I need to unpause this to do this, that's great. You learn where you got stuck and what part you need to learn. But just watching it is probably not going to get you that much further than any of the other problems did. So go ahead and pause it, try this first, and then unpause it to check your answer. Alright, so I'm going to draw my triangle. I draw the same triangle every single time I do law of sines and cosines. Drawing the same triangle since I was in high school and I did this. So we've got A, B, C, B, A, C. Let's go ahead and label these things. We've got A is 66 degrees. B is 16. C is 21. So it says solve this whole triangle. That means we need all of these things. When you do these, I would suggest you guys just writing out a list so you know you have to solve everything in here. So you've got the measure of angle A equals and measure angle C equals, and then you also need to find A, B, and C. We already have A is 66 degrees. We've got C is 21, and B is 16. So we need to find these other things. This is kind of nice because they give you an angle, so you can find that last angle pretty darn easy. But let's go ahead and use A to find out side A first. Because we've got angle A, so that just makes that super nice to type that in your calculator. You don't really have to solve an equation per se. So you've got A squared equals B squared plus C squared minus, not equals, 2BC cosine of A. A squared, we don't know. B is 16. C is 21 minus 2 times 16 times 21 cosine, and A is 66 degrees. Type that in your calculator, and let's see what we get. A squared is gonna be 423.67. We can write the 29, but it's probably not gonna make a huge difference. One thing I just thought of, you guys, when you do type this in your calculator, those parentheses, just type it in exactly that way. Don't type in 2 times 16 times 21. Just use your parentheses. That means multiplication. Okay? Now, we need to square root both of these sides. We get A equals, remember these are opposite, so the square goes away. 20.58 is 20.6. So this is 20.6. We got to get that one with law of cosines because this is not a right triangle. We cannot use Pythagorean theorem. Alright, at this point, you guys, we have sine angle side here. We could totally do law of sines, or we could do law of cosines to find one of those other angles. I'm going to do law of sines because, let's be honest, it is so much shorter. So let's do, let's find B. So let's do 16 over the sine of B equals, and if I'm going to do that, I got to use A because I don't have angle C, so I can't use C. So I got 20.6 over the sine of 66. You guys know I like to call this sombrero method just because I think it's funny, but really you're cross multiplying here. So multiply, divide, make your sombrero. So you've got 16 times the sine of 66 over 20.6 equals the sine of B. Put that in your calculator, and you get about 0.70954, and it'll keep going. Remember, we want these to be less than 1, or between -1 and 1, because they don't get any bigger than that on your unit circle. If you get something bigger than that, you can't do that. It's going to say error on your calculator because it's not possible. So these go away. We're going to take the sine inverse. So type this in your calculator. 0.70954 is 45 point, let's just do 2. And that is angle B. So we're going to say it's degrees, 45.2 degrees. And let's go ahead and subtract those from 180. So 180 minus 66 minus 45.2 is 68.8 degrees. Alright, that's everything for that problem. You solve for every single side and angle, so you're done at this point. You could have gotten there a multitude of different ways. You definitely had to use law of cosine at some point in there, but you could have used law of sines on that last part like I did, or you could have used law of cosines again. That is everything, so make sure you got that filled in on your notes, and then you should be pretty ready for your practice. I do think, because you don't have any of these ambiguous cases or solutions that don't work with law of cosines like you do with the law of sines, I do think this is easier. I think you guys will do well on this, and then you can use law of sines, but you just have to do it. You're not looking really at those ambiguous cases. You got to keep those in mind, but I feel like that tough piece is kind of out of there with the law of sines. You definitely have to know it for your test, though. If you have any questions, make sure you email me or come to my classroom.